Welcome to COIS ADMN 1620, Introduction to Information Systems. This is Chapter 8, Wireless, Mobile Computing, and Mobile Commerce. Learning Objectives. Identify advantages and disadvantages of each of the four main types of wireless transmission media. Explain how business can use short-range, medium-range, and long-range wireless networks. Provide a specific example of how each of the 5 major m-commerce applications can benefit a business. Describe the Internet of Things, along with examples of how organizations can use the Internet of Things. Chapter Outline. 1. Wireless technologies. 2. Wireless computer networks and Internet access. 3. Mobile computing and mobile commerce. And 4. The Internet of Things. Opening case. Mobile wallets in Canada. What we want you to think about here is, how do you make your everyday payments? Do you use multiple methods? Are security concerns affecting your choices of payment methods? Wireless technologies. Terminology: wireless, mobile computing, mobile commerce, and the Internet of Things, which is also known as IoT. Wireless devices, including smartphones. Wireless transmission media, microwave, satellite, and radio, and wireless security. The term wireless is used to describe telecommunications in which electromagnetic waves, rather than some form of wire or cable, carry the signal between communicating devices, such as computers, smartphones, and tablets. We want to distinguish the difference between wireless and mobile. Wireless just means without wires. Mobile refers to something that changes its location over time. Some wireless networks, such as MiFi, which we'll discuss a little later on, are also mobile. However, others are fixed. For example, microwave towers form fixed wireless networks. Mobile computing refers to real-time wireless connection between a mobile device and other computing environments, such as the Internet or an intranet. Mobile commerce, also known as m-commerce, is e-commerce transactions conducted with a mobile device. The Internet of Things is a scenario in which objects, animals, and people are provided with unique identifiers and the ability to automatically transfer data over a network without requiring human-to-human or human-to-computer interaction. Wireless devices have 3 major advantages for users. They're small enough to easily carry or wear. They have sufficient computing power to perform productive tasks, and they communicate wirelessly with the Internet and other devices. The one major disadvantage for businesses is that workers can capture and transmit sensitive, confidential, or proprietary information using their wireless devices. There are workplaces where you are not allowed to carry your mobile device due to the confidential nature of the business. Figure 8.1. Dematerialization with smartphones. Dematerialization is a process that occurs when the functions of many physical devices are included in one other physical device. Think about all the things that your smartphone can do and all the equipment that it has replaced. It's replaced, obviously, the wireline telephone. You have a flashlight. You can watch TV. You can listen to music. You can watch movies. You have calculator functions, you have a video camera, you have a camera, there's a compass app, you have access to the Internet for encyclopedia replacement, you can read books, and you can type text, all on a single smartphone. It's about Business 8.1, Smartphones Impact Healthcare. What we want you to think about here is, how many different IT-based systems could your doctor use? Would you rely on only an app for your medical testing? Why or why not? Wireless transmission media. Wireless media, also known as broadcast media, is used to transmit signals without wires. There are 3 major types of wireless media channels: microwave, satellite, and radio. Table 8.1. Advantages and disadvantages of wireless media. Microwave. The advantages are high bandwidth, and it's relatively inexpensive. The disadvantages are that it must have an unobstructed line of sight and it's susceptible to environmental interference. Satellite as a channel has high bandwidth and a large coverage area, as its advantages. Its disadvantages are it's expensive, and it also must have an unobstructed line of sight. The signals experience a propagation delay, and it must use encryption for security. Radio as a channel has high bandwidth and signals pass through walls. It's inexpensive and easy to install as its advantages. Its disadvantages are it creates electrical interference problems, and it's susceptible to snooping unless it's encrypted. Three basic types of telecommunications satellites: geostationary Earth orbit, GEO, middle Earth orbit, MEO, low Earth orbit, LEO. Figure 8.2, comparison of satellite footprints. You can see that the geostationary Earth orbit is the highest, the middle Earth orbit is in the middle, and the low Earth orbit is not all that high above the Earth. Table 8.2, geostationary Earth orbit. The orbit is at about 35,900 kilometers above the Earth. There are 8 satellites. They're used for TV signal. Their characteristics are that the satellites are stationary relative to the point on Earth. In other words, they stay in the same place in the sky when you look at them from the ground for the people that can see them. Very few satellites are needed for global coverage, hence the 8. There's a transmission delay because of their distance above the Earth of approximately a quarter of a second. They're the most expensive to build and launch, and they have the longest orbital life. They last for many, many years. Middle Earth orbit. The orbit is at about 10,350 kilometers. There are 10 or 12 of these satellites. They're used for global positioning satellites. Their characteristics are that they do move relative to a point on Earth. A moderate number are needed for entire global coverage. They require medium powered transmitters. There is a negligible transmission delay because they're a lot lower. They're less expensive to build and launch. They have a moderate orbital life of 6 to 12 years. Interestingly, and unrelated to this course, GPS satellites experience time differently because of their position relative to gravity than we do on the surface of the planet. Therefore, there is an adjustment that has to be made mathematically for calculations with respect to GPS because they don't experience time the same as us. Low Earth orbit. They orbit at around 640 meters to 1.12 kilometers. There are many, many satellites. Their use is for telephone and internet. They move rapidly relative to a point on Earth, and because they're so low, there's a large number needed for global coverage. They require only low power transmitters. There is a negligible transmission delay, again, speed of light and a kilometer or so away. They're the least expensive to build and launch, and they have the shortest orbital life, as low as 5 years. Global Positioning Systems, GPS. They are a wireless system that utilizes satellites to enable users to determine their position anywhere on Earth. They are supported by those middle Earth orbit satellites. They're used for navigating, mapping, surveying, and 911 location. There are 3 additional GPS systems planned or operational, one for Russia in 2011, one from the EU in 2016, and one from China in 2020. Figure 8.3, obtain GPS information in an automobile. I think we're all aware of the use of either Google Maps or Waze or other navigational devices, whether they are on our phones or our mobile devices or built into our automobiles. Additional satellite applications. Internet over satellite. That's a way to access the internet without cable. It's used when cables are too expensive or physically impossible, for instance, rural or far northern areas. Commercial imaging. Satellite-based Earth images are used for tracking moving objects, for instance, ships and planes, zooming in on physical objects, for instance, roads and buildings, or examining sky and land, forests, farms, and weather. The images can be integrated with other data, such as census data, to monitor urban development. Radio and other internet access methods. Radio transmission. This is used to connect computers to peripheral equipment and local area networks. It can be ground-based directly between transmitters or receivers, or as satellite radio, i.e. digital radio, that is provided via satellite. Google Loon. Balloons provide internet access by creating aerial wireless networks. Internet blimps. They provide the functionality of cellular towers with a larger footprint. Wireless security. Wireless networks obviously provide numerous benefits for business, but they are a huge challenge from a security point of view. They have an inherent lack of security. Wireless is a broadcast medium. Transmissions can be intercepted by anyone that's within range and has access to appropriate equipment. The main issues are rogue access points, which is an unauthorized access point into a wireless network. It could be someone in your organization who has set up an access point meaning no harm, but doesn't inform IT and therefore doesn't have the same level of security. This has happened in the company that I work for. In a more serious or malicious case, the rogue is an evil twin of someone who wishes to access a wireless network for malicious purposes. In an evil twin attack, the attacker is in the vicinity with a Wi-Fi enabled computer and a separate connection to the internet. Using a hotspotter, which is a device that detects wireless networks and provides information on them that the attacker simulates a wireless access point with the same wireless network name or SSID as the one that the authorized users expect. If the signal is strong enough, users will connect to this fake system instead of the real access point. War driving is the act of locating wireless local area networks while driving or walking around a city or wherever. To war drive, you simply need a Wi-Fi detector and a wirelessly enabled computer. If a wireless local area network has the range that extends beyond the building where it's located, you might be able to park in a driveway or park in an adjacent parking lot and intrude into the network. Eavesdropping refers to efforts by unauthorized users to access data that are traveling over wireless networks. Radio frequency jamming, a person or a device intentionally or unintentionally interferes with your wireless network transmission. Wireless computer networks and internet access. We're going to discuss three separate networks: short-range wireless networks, medium-range wireless networks, and wide-area wireless networks. Short-range wireless networks. These consist of Bluetooth, personal area networks, ultra-wideband, and near-field communications. Bluetooth is an industry specification used to create small personal area networks. We use it for speakers and earbuds, things like that. A personal area network is a computer network used for communication among computer devices located very close to one person. Bluetooth is low power and it's radio-based in its communication. Ultra-wideband is high bandwidth wireless technology with transmission speeds in excess of 100 megabits per second. Humatics is a pioneer in UWB technology and has developed many UWB applications. The applications include things like mobile robotics, heavy equipment industries such as manufacturing and mining, and defense and security for wireless perimeter fences. Near field communications, NFC, has the smallest range of any short-range wireless network, and it's designed to be embedded in mobile devices such as cell phones and credit cards. When you're using NFC, you can tap your card on a point-of-sale terminal to pay for items. Medium-range wireless networks. Wireless fidelity, which we know as Wi-Fi. We have wireless local area networks, WLAN, wireless access points, and hotspots. There's also Wi-Fi Direct, MiFi, and Li-Fi. Until late 2010, Wi-Fi could only operate if the hotspot contained a wireless antenna. So organizations typically used Wi-Fi for communications of up to about 250 meters, and for shorter peer-to-peer connections, they used Bluetooth. Once the introduction of a new iteration of Wi-Fi known as Wi-Fi Direct came on board, it enabled peer-to-peer communication so devices can connect directly. Users can transfer content among devices without having to rely on a wireless antenna. Devices with Wi-Fi Direct can broadcast their availability to other devices, just as Bluetooth devices can. Wi-Fi Direct is compatible with more than 1 billion Wi-Fi devices currently in use. Wi-Fi Direct will probably challenge the dominance of Bluetooth in the area of device-to-device networking because it offers a similar type of connectivity with a much greater range and much faster data transfer. MiFi is a small portable wireless device that provides users with a permanent Wi-Fi hotspot wherever they go. Therefore, users are always connected to the internet. The range of a MiFi device is about 10 meters. They are developed by Novotel, and the MiFi device is also called an intelligent mobile hotspot. Accessing Wi-Fi through MiFi allows up to 5 persons to be connected at the same time, sharing the same connection. MiFi also allows users to use voice over IP technology that we've discussed previously to make free or inexpensive phone calls. MiFi provides broadband internet connectivity at any location that offers 3G cellular network coverage. The one drawback is MiFi is expensive, both to acquire and to use. Li-Fi, or light fidelity, is a technology for wireless communication among devices using light to transmit data and position. Li-Fi is a visible communications system that can transmit data at high speeds over the visible light spectrum, ultraviolet, and infrared radiation. The use of light to transmit data offers some advantages over Wi-Fi. Li-Fi provides a far greater bandwidth capacity. It provides very high peak transmission rates, and it enables communications among 100 times more devices on the Internet of Things. It also provides enhanced security due to the reduced interception of light signals versus radio signals, and it's more effective in areas susceptible to electromagnetic interference, such as aircraft cabins and hospitals. Figure 8.4, wireless access point. This is a demonstration of a Wi-Fi access point. You will often see these with multiple antennas. Mine at home has 4 antennas. This is often due to having multiple different bandwidths that you can connect with for your guest network versus your prime home network. Wide area wireless networks. Cellular radio or cellular telephones. We've got 1G, 2G, 2.5G, 3G, 4G, and 5G. The CDMA, EVDO, HSPA, GSM, LTE, XLTE are different protocols that are used over those networks. Those are things that I studied in depth when I was doing cellular phone acquisitions and forensic analysis. There's also wireless broadband or WiMAX. Figure 8.5, a cellular network and the public switched telephone system. Cellular phones provide a two-way radio communication over a cellular network of base stations with seamless handoffs as you're in motion. Cellular phones differ from cordless phones, which offer a telephone service only within a limited range through a single base station attached to a fixed landline, for instance at home or in an office. The cell phone communicates with radio antennas or towers placed within adjacent geographic areas called cells. Those are represented in the diagram by the hexagons. It's about business 8.2, 5th generation 5G mobile networks. What we'd like you to consider here is, do you use virtual reality applications? Where else might 5G be helpful to you? How could 5G assist organizations who needed to adapt to social distancing requirements? Wireless broadband or WiMAX. Worldwide interoperability for microwave access, WiMAX. It's the IEEE standard 802.16, wireless access range of up to 50 kilometers, and data transfer of up to 75 megabits per second. It's a secure system offering voice and video. It's personal, wireless, and mobile. What we'd like you to consider here is, do you know which cellular radio speed your smartphone is using? Have you ever run a speed test with your phone? Are you going to try it? Mobile computing and mobile commerce. Mobile computing is a real-time connection between a mobile device and other computing environments, such as the internet or an intranet. Mobile commerce is electronic commerce transactions conducted in a wireless environment, especially via the internet. Mobile computing. It has two major characteristics, mobility and broad reach. Mobility and broad reach create 5 value-added attributes: ubiquity, convenience, instant connectivity, customization, and localization. Ubiquity means something is available everywhere. A mobile device can provide information and communications regardless of the user's location. With an internet-enabled mobile device, users can access the web, intranets, and other mobile devices quickly and easily without booting up a PC or placing a call through a modem. Those speak to convenience and instant connectivity. A company can customize information and send it to individual consumers as an SMS or short message service. That's customization. And knowing a user's physical location helps a company advertise its products and services, which is localization. Mobile computing provides the foundation for mobile commerce. Mobile commerce, also known as m-commerce. The drivers of m-commerce are widespread availability of mobile devices, the declining prices of those devices, and the improvement of bandwidth. Mobile commerce applications. Financial services, location-based applications and services, mobile advertising, intra-business applications, accessing information, and telemetry applications. Intra-business applications are when you're using your mobile device to perform some integral part of workflow applications within your company. Telemetry applications are things like identification of maintenance problems in equipment like cars, or doctors monitoring patients and controlling medical equipment from a distance. It's About Business 8.3, Gas Buddy. What we'd like you to consider here is similar apps could be used to report stores that are open or closed in a particular area. What do you have a problem finding? Are there other products with shortages you could look for using an app? The Internet of Things, IoT. This is also known as the Internet of Everything, or the Internet of Anything, or machine-to-machine M2M communication. Radio frequency identification, RFID, can be active or passive. RFID versus barcodes, which are known as UPC, Universal Product Codes, and RFID versus QR, Quick Response Codes. Figure 8.6, barcodes, RFID tags, and QR codes. So a QR code is becoming increasingly familiar to most people. RFID tags can be used to locate goods and track their movements. Barcodes are the classic way of identifying products, and with the use of a scanner, being able to move those products from location to location. QR codes have some advantages over barcodes. QR codes can store much more information. Data types stored in QR codes include numbers, text, URLs, even Japanese characters. They're smaller because they store information both horizontally and vertically. They can be read from any direction or angle, so they're much less likely to be misread, and they're more resistant to damage. RFID systems use tags with embedded microchips. Those microchips contain data and antennas to transmit radio signals over a very short distance to RFID readers. The readers pass the data over a network to a computer for processing. The chip in the RFID tag is programmed with information that uniquely identifies that item. Figure 8.7, small RFID reader and RFID tag. This demonstrates a picture of using an RFID reader and tag in a grocery store. It's About Business 8.4, Marks & Spencer embraces RFID. What we'd like you to consider here is the importance of avoiding stockouts. Would you go back to a store if it did not have your size of clothing? How could the benefits of RFID labeled inventory be used for online shopping from Marks & Spencer? Examples of the Internet of Things in use: a smart home, digital twins, healthcare, automotive industry, supply chain management, and environmental monitoring. In a smart home, your home computer, TV, lighting, heating, home security, thermostats, appliances all have embedded sensors and can communicate with one another through a home network. You can control them all through various devices, including your smartphone. Digital twins. A digital twin is a virtual representation of a real-world product or service. Consider a wind farm. Outfitted with sensors, the physical parts of a wind farm feed sensor data to its digital twins. Those are computer models that constantly monitor the data of the real-world turbines, and if there's a problem that's potentially going to occur, then the digital twin can predict it before it happens. In healthcare, patients with non-life-threatening conditions can wear sensors or have them implanted, for example, to monitor blood pressure or sugar levels. Automotive. Modern cars have many sensors connected to the internet that monitor functions such as engine operation, tire pressure, fluid levels, etc. Cars can warn drivers of impending mechanical or other problems and automatically summon roadside assistance or emergency services as necessary. Supply chain management. The IoT can make a company's supply chain much more transparent. They can track in real time the movement of raw materials and parts through the manufacturing process to finished products delivered to the customer. Sensors in fleet vehicles, such as delivery trucks, can monitor the condition of sensitive consignments, perhaps the temperature in perishable food. They can also trigger automatic security alerts if a container is opened unexpectedly. Environmental monitoring. These are sensors that monitor air and water quality, atmosphere and soil conditions, and the movements of wildlife. Continuing, examples of the Internet of Things. Infrastructure management, energy management, agriculture, enabling precision agriculture, transportation, and farming. Infrastructure management uses sensors to monitor infrastructure such as bridges, railway tracks, and roads. They can identify and report changes in structural conditions that could compromise safety. Energy management, you can put sensors into all forms of energy consuming devices, switches, power outlets, light bulbs, televisions, and they will be able to communicate directly with utility companies through smart meters to balance power generation and energy usage. Agriculture. Sensors monitor in real time air temperature, humidity, soil temperature, soil moisture, leaf wetness, atmospheric pressure, solar radiation, and so forth. And the data from these sensors are used in precision agriculture, which is a farming technique based on observing, measuring, and responding to inter- and intra-field variability in crops. Transportation. We can place sensors on complex transportation machines such as jet engines and locomotives, which can provide critical information on their operations. Farming, using a number of steps a cow takes, it is possible to detect as many as 10 different diseases. Using this application of the Internet of Things, Japanese farmers were able to significantly increase their herd size and the health of their cows. Closing case, Google Fi. What we want you to think about here is, how does Google Fi compare to your telephone or data plan? Would you pay by usage, or would you prefer a plan such as an unlimited plan if it were available? That brings us to the end of this chapter's lecture. Thank you for your attention.